So, welcome guys. For lesson plan I, the question we are going to consider here is the integral of xn then cos x. Like I explained in the previous video, if you want to work with xn then cos nx, it's a very complex one. So this should be the question. Trivially, this should be the question. So let's just quickly work on this. From here, since we have this, we can easily um let you can just use integration by part by saying let u represent cos x, and then dv will represent the remaining part, the remaining portion of the under the integral, which is xn dx. So considering this, we need to find du dx such that when you differentiate this, you have negative of sine x, right? And then when you integrate both sides there, I will end up having v equals, integrate this, I will have xn plus 1 all over n plus 1, right? And then the integral given to us from the question, by the use of integration by parts, we have uv minus integral of v du, right? And then u itself represents cos x, and then the v we got just now is xn plus 1 all over n plus 1, then negative sign integral of xn plus 1 over n plus 1, then with this result, that is du is minus sin x, du is minus sin x, and then finally with dx, when you cross multiply, du is minus sin x dx, right? So from here, the integral of xn cos x dx is equals to xn plus 1 with cos x over n plus 1. The minus times minus gives us this plus, and then we end up having integral of what? Xn plus 1 sin x dx. Now looking at this, we can decide to use division by part again. Yeah, can decide to use division by part by saying let the same process. We let u to be equals to sin x again, just like what we did earlier, and then we let dv to be equals to xn plus 1 then dx, such that du becomes cos x dx trivially. And then when you integrate both sides there, I will end up having v represent, integrate the v, you have v, then integrate this, that will be xn plus 1 plus 1, that's plus 2 over n plus 2. So by the time we recall, this is where we stop. Xn cos x dx is the question. Then we end up having xn plus 1 with cos x over n plus 1, and then with plus. The whole of this is where we actually started using the integration by part, which is uv minus integral of v du. And then u itself represents sin x in this case, and then v gives xn plus 2 over n plus 2. Do you get that now? And then this integral of v du also will be xn plus 2 over n plus 2, and then du gives us cos x dx. So when we proceed with this, we end up having integral of xn cos x dx to be equals to xn plus 1 cos x over n plus 1. Then with this positive sign we have here, when you open this bracket up, plus times this, we end up having sine x with xn plus 2 over n plus 2. Then plus times minus is minus. This 1 over n plus 2 will come outside from the bracket. Then we'll be left with just integral of xn plus 2 then cos x dx. So this should give a reasonable result, rather than having a question with xn cos nx. No, it's going to be a very complex one. So I prefer, the question should have come this way. So now trivially, you are very close to the final answer. We can easily make an assumption from here. Since, okay, we should have make an assumption in this case, that is, let this represent in. Trivially, if this represents in, right, xn cos x, then automatically speaking, if you have n plus 2, then this represents in plus 2. So automatically speaking, we have xn cos x ds, which represents in. Then this in here becomes the result I have there, which is xn plus 1 over n plus 1, of course, x, added with xn plus 2 of sine x all over n plus 2 with negative of 1 over n plus 2. Then the whole of this represents I n plus 2 from the assumption. So this gives the final answer, or you say this is actually equivalent to, you can easily fact, this is the final answer for the question. Or you factor it out by saying we have xn plus 1, of course x, over n plus 1. And whatever I notice here that what I actually notice in these two terms here is that 1 over n plus 2 is common. So whatever I have left is just xn plus 2 of sine x minus I n plus 2. So this is what I have left. So this gives the final answer to the question. So thank you very much. So this end the explanation to reduction formula. So the next topic we are going to be considering is the Leibniz theorem. So see you guys in the next video. Thank you very much.